We're going to go ahead and get started. I would like to thank everyone for logging into our webinar today on concrete overlays over existing asphalt parking lots. My name is Theron Tobalski, and I'm the Assistant Executive Director with the Illinois Ready Mix Concrete Association. Part of my responsibility is working with the engineering community to kind of understand everything concrete, and then to work with the engineering community on any kind of engineering help that they need in specifying any of these type of topics they hear about. Opening comments. We are going to follow the Illinois Ready Mix Concrete Association antitrust policy. It is posted on our website on the webinar page. Every individual webinar that we have has its own webinar page, has all kind of links on it, and the antitrust statement is posted on each of those webinar pages. This webinar is being recorded. Every recorded webinar does get posted on the webinar page. It's a great tool for you to go back and listen to anything that you might have missed or something you need clarification on. Again, you can go to www.nrmca.org. On that web page, when you go on the webinar web pages, we have our sponsors. Here's a list of the sponsors for today. On the web pages, some of these people have put in links to information on all different concrete topics, technologies, or information that they feel you as an engineer would want to read about. So I'd encourage you to go to the website, look at the different webinars, and look at some of the links that they have posted there. And with that, I'm going to go ahead and introduce my speaker. Today we have Don Clem with the National Ready Mix Concrete Pavement Association. He's from Colorado. He's the Vice President of local paving. And with that, I'll turn it over to you, Don.
Great, thanks, Theron. Bear with me a second. You should see my title slide. Are we good? All right, great. Thank you, and I am glad that we're going to have an hour, lunch hour to spend together to talk about concrete overlays. I appreciate Theron inviting me today. My name is Don Clem. I'm with the National Ready Mixed Concrete Association. I'm a paving engineer for the association, and I just want to cover a little bit about NRMCA. We are a national trade association whose membership is derived from the concrete ready mix producers across the country. Our mission is to serve, sorry about that. Our mission is to serve our industry and partners through several actions, including promotion of concrete pavements and ready mix products in buildings. We have a couple initiatives that you can see here and sites you could go to, paveahead.com for paving. And we have a Build with Strength initiative for concrete buildings. This is our local paving team, as you can see here. We do have experts across the country, and Theron has access to this team that you see here. This is me, and my territory is the Rocky Mountain Northwest area. We always put up a disclaimer for NRMCA presentations. Basically, I'll give you just a minute to take a look at that. Bottom line is we at NRMCA strive to present information as accurately as possible. We intend for you to utilize this information at your discretion, and we do disclaim responsibility for how the information is applied. Our objectives today are to learn how to evaluate and assess an existing asphalt parking lot for the feasibility of a concrete overlay, understand how to determine the thickness, learn the various construction techniques and how to determine the proper joint spacing. That goes hand in hand with design, and then finally discover which details and specification criteria are especially important for these projects. Our resource primarily is this green guide, we fondly call the green guide, Guide to Concrete Overlays of Asphalt Parking Lots. This is published by the National Concrete Pavement Technology Center, which is out of Iowa State in Iowa. And this is a very well-written guide. So the green guide is for parking lots. That's going to be the basis of our presentation today. Very easy to read. And then we also have, I put in here just as a reference, the blue guide, which is the Guide to Concrete Overlays, and that's for roadways and streets. And it is an excellent publication as well. The green guide was published in October of 2012, and we're in the process right now of rewriting that guide. So just a little of my background. I've been in the industry since the early 80s, and actually my early career was a land development engineer for about 10 years, and then I moved into the concrete industry after that point. And most of my career has been in Colorado, working in the concrete industry, a lot of it designing pavements. And I'll give you just a brief history of pavements in Colorado, the overlays in Colorado. We really started those about the time I started in the industry, the late 80s. And Illinois, I would note, has built a lot of concrete overlays. Colorado, just the DOT has built over 1.5 million square yards of 6-inch overlay, and also 10 million square yards of concrete overlays of all thicknesses. So they've done quite a bit more of the 8 and 9-inch overlays on state highways. They did a lot of that early on. But talking about parking lots, which is our focus today, first one I was aware of in Colorado was a doctor's office in Monte Vista. This gentleman's Leonard Velasquez, contractor down in that San Luis Valley. And this project that he built in '88, this is a photo 30 years later in 2018, was supposed to be a remove and replace of an asphalt parking lot with concrete, but the subgrade was so bad it wouldn't support the equipment as they were trying to tear out the asphalt. So they decided to do an overlay. They had read about it in a magazine and sort of just did it without a lot of knowledge. And as you can see, it's still holding up today. There's a few cracks, but 30 years is pretty good performance. Another old one, 1991, was the Queen of Vietnamese Martyrs Church. Interesting story here is this parking lot, which is pretty good size, was built by the parishioners. It was really an interesting project to watch. They used 2x4s as the forming material. 2x4 is the screed. Very rough construction, as you can imagine. But after 30 years, you can see that this parking lot has really served them well. You can see how rough it is just by looking at the picture, but you can see an area here that they have replaced and an area here. Other than that, this is all the original overlay that those parishioners built. And they were able to do that cheaper than an asphalt overlay since they did the labor themselves. That's a unique situation. The last project I'll show you as far as a roadway in Colorado is this is actually Interstate 70. And this is a 6-inch overlay with 6 by 6 foot joint spacing. And we call that our 6 by 6 Colorado, 6 by 6 by 6 Colorado overlay. The reason I put this in here is I just want to illustrate on the top end of what these overlays can carry. So this is a 6-inch overlay on I-70. It's about 5 miles in from the western border of Colorado with Utah. It's a 5-mile project on both sides of the roadway. I took this picture when it was 5 years old, and I couldn't find a crack in it as I was driving down each of the sides of the interstate. And for the pavement engineers on the call, the design traffic on this, if memory serves me right, was about 8 million easels. So pretty good traffic, and 5 inches is I'm sorry, 6 inches is carrying that traffic. I think this was on about 8 inches of asphalt. So that's just to illustrate kind of the top end of what these bonded concrete overlays can do. So you're probably asking, why specify a concrete overlay? Well, there's quite a few reasons, but probably the biggest reason is economics. And we find that many times it's cheaper to go with a concrete overlay over an asphalt parking lot compared to remove and replace. So if we're looking at remove and replace, basically at the end of the life of the asphalt parking lot, keep in mind that these overlays can actually be less expensive, and on the order of about 30% has been my experience. It's a better use of materials because the owner has already paid for the asphalt in the base, so why not reuse it as opposed to tearing it out and paying somebody to haul it off? It just doesn't make a lot of sense. This is a much more sustainable type of an approach. Once you create the concrete overlay, then you're going to minimize your future costs because basically you have a concrete parking lot from that point on, just setting on a very good base. And then finally, you're going to have a bright welcome mat for your business. It's really it transforms the parking lot from a problem into something that attracts businesses. And of course, you get the other benefit at nighttime of the reflectivity of a lighter pavement material. Here you can see these are actually LED lights that were put in with this project. This is a concrete overlay, but I put it in just to illustrate the brightness of the concrete parking lot. So let's talk about parking lot selection, because that's really important. That's the key to a successful project, is to determine if a project is a good candidate. An asphalt parking lot is a good candidate for a bonded concrete overlay, or perhaps it may not be. And it's real critical to be able to discern the difference between the two. I'll mention here that the two types of overlays for an asphalt parking lot are bonded or non-bonded. We would always rather prepare a bonded or design a bonded overlay if we have everything else equal, because a bonded overlay, which is going to behave as a composite pavement with the asphalt, is going to be less thickness. And generally an unbonded overlay is going to be about 1 inch to 1.5 inches thicker than a bonded overlay. So a bonded overlay is going to be more economical where we can do that. So when I look at a parking lot as a candidate, I'd always like to do a bonded overlay to begin with, but then we may rule out certain parking lots as unsuitable. But it's always necessary to go through this step to confirm suitability. And what we're going to look at, and this is right out of the green guide, is different types of distresses that we typically run into with asphalt parking lots. And we're going to put them into categories of low to moderate severity or high severity surface distress. If we're in the low to moderate, that's going to be a good candidate for a bonded concrete overlay, as long as the thickness is there. If not, then we may have to look at something like an unbonded overlay, or perhaps a remove and replace at that point. So there's 3 steps that the guide puts out as far as determining the suitability. One is to review the existing information, plans, maintenance records, history, things like that are there. Second, determine the existing conditions. And then third, you want to compile that information. So we start with a review of information that is on hand, any kind of written information, performance history, estimated remaining life, current and desired future traffic. So we're really trying to find out everything we can about the parking lot. We're looking for any problems associated with the parking lot, such as drainage. we really want to uncover everything we can about that history of that parking lot. And some of the items that we might turn to or look for: design reports, geotechnical reports are good to determine, give us an idea of the properties of the soils below the pavement. Construction plans are great, past condition surveys if they exist, maintenance and repair histories, particularly overlays, history of overlays that might have occurred. And if any kind of traffic measurements are forecast, particularly if the traffic is going to change with this new parking lot, you certainly need to know that. And the next step, which is probably the most important, is actually go out to the parking lot and review what you have out there. Do a assessment on site. We want to determine the type and severity of any pavement distress and condition of the subgrade. So we're looking to do some cores, or at least drill some holes so we can see how thick the layers are and see what kind of shape the materials are in. We also want to look, if there are distresses, we want to determine the cause of those distresses. Is it a drainage issue? Because if it is, with the when we design an overlay, we want to make sure we address any drainage or other potential problems. And then finally, we want to look to see what kind of elevation constraints we might have. Are we surrounded by garages where we have to tie in to an elevation? Or do we have a situation where we have a curb and there's really just landscaping behind it where we can overlay the curb? Those are the types of things we're looking for. So I mentioned we definitely want to take cores. Very critical that we know how thick each of the layers are, and we have to take enough cores to have some confidence of what the minimum thickness is, because we always design based on the minimum thickness that we find in a given area. It's also important to note if there's any fabric between the layers of asphalt. And I put this in here because I had this particular issue out here on a project. We had some cracking in a very limited area. And after about 5 years on a concrete overlay, and the contractor went in and he tore the section out and he put it back in full depth. When he tore it out, what we found was there was a interlayer fabric between the two asphalt layers. So where we had planned on a 4-inch concrete overlay over, I think it was a 3 or 4-inch asphalt layer, and we had designed as a composite pavement, we found fabric in between the asphalt layers, and that served as a bond breaker. So in effect, we only had really 2 inches of asphalt, maybe even 1.5 inches that we were bonding to. So that was a partial problem that led to the cracking that we observed. So always look for this fabric. If you find the fabric in there and it's acting as a bond breaker, which it typically will, then you probably don't want to design a bonded overlay. You might want to look at an unbonded overlay in that situation, or maybe even a removal and replace. And then finally, you want to take enough cores to make sure that you're confident of what the thickness of the asphalt is out there. It really is a critical element. So I show this. This is right out of the guide, and this is what happens when you put a thin section of concrete that's designed as a bonded overlay on asphalt on grade instead of asphalt. This is setting right on the subgrade, and they actually milled this surface as a preparation and went entirely through the asphalt here. So basically they had no asphalt left as a base. And this is what you might get. This is a fatigue failure from that. And I have experienced this myself. We did an experimental project in about 91 or 92 with the Department of Transportation out here. We had the same thing happen. We punched right through the asphalt to the subgrade. And what we did is we wanted to test concrete overlay bonded. So what we did is we put a new layer of asphalt back in there, thinking we're trying to test that as a bonded overlay, the concrete, and what happened was that didn't work with the new asphalt because we didn't get bond. As many of you know on the call, new asphalt acts as a bond breaker. So we learned that lesson pretty quick. It didn't look as bad as this, but it was pretty bad. And actually, after almost 30 years, I go by this project about once a month, and it's still in place. The fibers are holding it together, but it really looks bad. So these are the type of stresses that are identified in the guide, and I'm going to go through these really quickly, but the guide will identify and have pictures of low to medium severity and then high severity. And generally speaking, what you're going to observe is, so this is alligator cracking. What you observe in the high severity is you're going to see some vertical separation here. There's a vertical component to high severity areas of distress. And that's going to be consistent through all of these pictures and types of distresses that we examine here. So this area, low to medium severity, is fine for a bonded overlay. The high severity is not. In this situation, if we have a lot of areas like this, we're going to look at an unbonded concrete overlay or perhaps a remove and replace. Block cracking, you see here, another type of asphalt distress. Again, low to medium on the left, high severity on the right. Potholes, raveling, you can see kind of a vertical component here. Thermal cracking, random cracking. The guide does a really good job, particularly for someone with a concrete background, of sort of outlining what you look for as far as distress with a asphalt pavement. So after we do this field examination of the project, and we've done the research for the design reports, and you speak to managers about what problems they have on the facilities, then you prepare this evaluation report. You pull all this information together, and at that point you're determining whether you can go forward with a bonded concrete overlay, unbonded, or what the best approach will be. In this, we say prepare a pavement report, but it may just be a one-page document. It's not necessarily a multi-page document. Depends on the size of the project and complexity. So just to recap, when we're looking at an existing parking lot, we want pavements that exhibit low to medium surface severity. We want at least 2 inches of asphalt. I prefer 3 myself, but the guide does go down to 2 inches. So we do offer design for 2 inches. And then we want minimal vertical constraints along the edges of the project relative to the area of the overlay. So this is sort of a judgment call, and I'll give you an example. If you had a fairly small parking lot, let's say it was a townhouse project, and you have this small parking lot, let's say it's just like 70 by 70 or 100 by 100, and it's surrounded by garages. It's surrounded by townhouses with garages. So all the way around this project, you've got to match to those garages. So you've got basically around the perimeter of this project, you're going to have to do a transition where you go from matching that garage up to an overlay, and you got drainage considerations, of course. But you've got probably anywhere from 5 to 10 foot of transition going from full depth up to the overlay, all the way around that area. Well, what you find is on a small project, by the time you put those transitions in, you don't have a lot of overlay left in the middle. It's really not worth it. Now contrast that with, let's say, the DIA project that I'll show you, which is over 30 acres, if memory serves me right. And let's assume that we had a transition around that 30 acres. Obviously, that transition pales in when you compare it to the overall size of the project. So that project is a very good project from an overlay, just looking at that transition component. So those are the types of things you're looking at with this particular constraints that we're talking about. And then finally, we want to make sure we don't have any paving fabric if we're going to design a bonded concrete overlay. So let's talk a little bit about thickness design and jointing design. They really go hand in hand, as you'll see. You're really designing a system that the thickness design and the jointing design are intertwined. So now we're going to focus a little bit more on the guide. So the tables in the guide are really meant for light duty parking lots. So we're not necessarily looking at industrial facilities. We're looking at shopping centers and golf courses and churches, typical municipal buildings. That's the type of parking lot envisioned when this guide was put together. The design is based on full or partial bond, as I mentioned before, which forms a composite pavement. And the key to this working is really the close joint spacing. And if you can imagine, that close joint spacing really reduces the stresses in the concrete pavement, because think of the moment arm as you look at a 4 or 5 foot joint. That's really a small concrete panel, and the stresses are greatly reduced by that small moment arm. The K values are out of ACI 330, which is the design guide for concrete parking lots, table 3.2. And the basis of the design is American Concrete Pavement Association's modified bonded concrete on asphalt design program. These are the design inputs. I won't bore you with these, but basically it's the same inputs for any concrete pavement design, with the addition of we've got an input for the existing asphalt thickness in the modulus, and also the pre-overlay surface preparation. Other than that, it's no different than designing any other concrete pavement. The guide operates on a zone concept. So this is a little bit different concept. Each area, there's 3 areas in the design. We'll go over those in a minute, but we use the zone concept. So zone 1, as you can see here, is the parking area, so mainly a car parking area. Zone 2 is the access road here shown in gray that surrounds the parking area. And then zone 3 finally is the truck area in the back of the building. So where trucks would access from here, unload in the building back here, and then exit out of there. So 3 different thicknesses, if you will, on a given project perhaps. So there's each table includes those 3 thicknesses. Now we have 3 tables in here. One for Des Moines area, which is probably what you would use being in Illinois. One is for Sacramento, and one is for Gainesville. So you can see that this is a mechanistic design. It takes into account the elevation, the weather patterns, moisture patterns for a given location. Existing asphalt thickness is 2 to 6 inches, joint spacing 4 to 6, fiber or no fiber condition, and then finally compressive strength 4,000 or 4,500. Design assumptions, probably the critical ones are the 20-year design, 30% slab cracks at the end of design, 80% reliability. Asphalt modulus of 300,000. And the other critical one would be this K value of 100, as I mentioned earlier. That's a fairly poor clay soil, which is typical in a lot of areas of the US. So here's what a chart looks like. This is the chart for Des Moines, and you can see we got zone 1, zone 2, zone 3. So let's assume we're going to design an access road for a project. So let's take a look at Des Moines, and perhaps we're in Illinois, so we're going to use the Des Moines chart. So the way we use this chart is very simple. we start over here with the existing asphalt thickness, and let's say we've determined that the minimum asphalt thickness is 3 inches. So we know we're going to be in one of these 2 rows, and the next decision we make is, do I want 4,000 psi or 4,500? If I'm in Illinois, I'm probably going to spec 4,500, and that's probably what I would spec here in Colorado, due to the heavy use of de-icing salts and a lot of freeze thaw cycles. So let's just assume 4,500. So that locks us into this row. Next decision is, do we want a no fiber condition or a fiber condition? I generally, for most parking lots, will go with this fiber condition. I like the extra protection of the macro fibers in there, and we are referring to macro fibers, not microfibers. So let's go with fibers. So now we are down to these 3 columns within this row. So you can see that we have 3 different solutions that would work for this situation, theoretical situation. We can go with a 3-inch thick concrete with 4-foot spacing, 3.5 inch with 5, or 4-inch thick concrete with 6-foot joint spacing. So perhaps an engineer could price out each one of these to see which is the most economical. When I do designs, I would generally probably fall to this one, the 3.5 inch with the 5-foot joint spacing. And what I'm trying to do there is balance the number of joints I'm going to have versus the thickness of the concrete. And I think I'd probably prefer this 3.5 with 5-foot joint spacing. Other engineers might have a different preference, but you can see your options there. So that's how you would design the thickness and the joint spacing of a parking lot. I want to mention what you might do if you have a parking lot that doesn't fall into those parameters that I've outlined. Perhaps the soil is a very strong sandy based soil, K value of 200. You may want to go to this other model. This is bonded concrete on asphalt ME, which was developed by Julie Vanderbosch out of the University of Pittsburgh. And this is primarily for streets, but you can certainly use it for parking lots as well in those different situations. And you can see here, I've just got a shot of some of the input values. This is the actual address. I generally just Google BCOA pit, and it will come up. And it's really a nice program. It's free to use. And you can put a hit graphical information button. That's the first input. And then select Illinois. And there's probably going to be about 6 or 7 cities that are going to pop up. Certainly Chicago, Springfield, and some other cities would pop up. You just select that city and it will populate latitude, longitude, elevation, and then you continue on with your inputs. So that's what you might do for a street. I'm not going to talk a lot on mixed design because there's really not a whole lot of difference between a concrete overlay and just an ordinary concrete pavement. But I mentioned you want to be at a 4:5 water cement ratio and 4,500 if you're in this freezing and thawing situation, exposure to de-icing chemicals. And I think that's pretty common, at least for the Chicago area. A little bit on fibers. They are very important in these overlays, and they reduce plastic shrinkage, cracking, plastic settlement, and they also increase the toughness and impact resistance. So there's a lot of benefits to fibers, but I do want to illustrate the difference between macro fibers, MICRO, and macro fibers. And there's quite a few differences. It's really an apple and an orange. And when we're talking about specifying fibers for overlay, and they're sometimes called structural fibers, we're talking about macro fibers. And so we'll start with micro though. They're fairly small fibers. They do help prevent plastic shrinkage, cracking. The dosage is normally fairly small, typical about 1.5 pounds of fibers per cubic yard. and they provide surface toughness. You see that these fibers are specified a lot of times. The microfibers are specified for concrete sidewalks by cities. You'll see them in a city spec quite a bit. Macrofibers, on the other hand, are larger, they're longer. They will actually reduce shrinkage cracking, and you can replace temperature steel reinforcement with these macrofibers, but the dosage is quite a bit heavier. It's 3 to 5 pounds per cubic yard typically. With that, let's move into construction. And Theron has been kind enough to provide more or less a case study which walks us through construction. So we're going to use that to illustrate a typical overlay, and it really has all the elements, so it makes a great case study in construction of an overlay. In this particular project, the full depth alternative was 1.5 inch surface course, 2 inches of base asphalt base, 12 inches of stone. The alternative was a 4-inch concrete overlay on a 5x5 saw cut pattern, 4 pounds of macrofiber. And you had some transition areas, but you can see the cost difference here. Initial cost saved the owner about $73,000. So pretty substantial savings for a small project. Here you see the outline. You can see the overlay areas here and here. Overlay for a roadway, overlay for a parking lot here, and you see the transition areas throughout the project. For the roadway, the contractor actually milled the surface to get a nice level surface that you can see here, and that's fairly typical of roadways. When we build concrete overlays for roadways in Colorado, we typically will mill about 1 inch of asphalt off, as long as we have enough asphalt that we can sacrifice that inch. That is critical. For most parking lots, we do not mill, because generally there's not enough asphalt in these parking lots that you could afford to mill, because you would be punching right through the asphalt with the milling operation. So here you can see the surface prep. It exists primarily of a power wash, and then you follow that with placement of the concrete right on top of that. The other nice thing about this process of washing the concrete down, you want to do that right in front of the paving operation as well, because it will cool that temperature of that asphalt surface off, because you don't want to be placing concrete on a surface that's higher than 120 degrees. So if you wet that surface down, the process of that evaporation is going to cool that existing surface. Here you can see some transition areas that we saw in that sketch earlier. Transition area here, transition area here. You've also got some tie bars tying into that existing concrete section there. And since this was a school, my assumption on the tie bars is they wanted to make really sure that they did not have any kind of tripping hazard there. So they put the tie bars in to lock that in. I mentioned that the mixed design was 4,500, 4 to 5 pounds of macrofibers. And you can see they're forming right on top of the asphalt and placing right on top of that cleaned, and it looks like it's moist asphalt. Just another shot. Then the concrete's leveled in the opposite direction to the paving train, and here you can see a razorback screed with a vibratory motor on it. This is a really nice way to build a project. You really get a good, this is probably the way we see most projects get built. I'll show you a couple other methods as well, but this the screed operation is probably most typical. And then finally, a broom texture is preferred surface. Now with the fibers, these microfibers, you can expect to see some of the fibers popping up through the surface, as you see here. Those will wear off over time, and you won't notice them after the pavement's been in service for a period of time. And there's the tie bars put in to make sure that there's no tripping hazard here, because I imagine you get a lot of pedestrian travel on that pavement. Existing sewers were raised and boxed out, as you can see here. That's pretty typical of any concrete construction, any parking lot construction. And then finally, the curing compound was put on. You really want to put a heavy coat of curing compound on these concrete overlays, particularly these 3 and 4 inch sections, because imagine what you've got is a thin section of concrete, relatively speaking, to what we normally have. So there's not a lot of moisture in that thin section, but you have a lot of surface area. So if you're operating in, for perhaps Colorado, where we have very low humidity, we might have wind, it might be hot, we lose a lot of water out of that pavement if we don't get that curing compound on quickly and get it on very, very thick. So that's one of the considerations that's a little bit more important with a concrete overlay than it otherwise might be for just a regular concrete paving project. You really want it to look like a white piece of paper. And then here you see the saw cutting operation. This is an early entry saw, which is typically what we see for these projects. You can make the cuts the same day. You always want to have a backup saw on a project, of course, just like you would for any concrete pavement project, but it's a little bit more important because of the number of saw cuts that you have to make on these projects. You've got a lot of joints. And then an independent lab of record should be hired by the owner. And of course, all the testing should be done by ASTM standards, and the cylinder should be cured by ASTM standards, of course. So this is very, very typical of what I see for asphalt parking lots that receive concrete overlays. So this is very, very typical. This would be your before shot, and here's your after shot. So take a look at how that transformed this this school. If you can imagine the school looking like this, and then after the project was complete, it looks like this. So that's the beauty of a concrete overlay. It's hard to put that value on paper, but a picture is worth 1,000 words, I think, and that just it looks like a different facility to me. It really dresses that facility up. Let's talk a little bit about details. I'm kind of watching my time. I want to make sure I don't run out of time. So as I mentioned, there's a couple of different ways you can address curb and gutter around one of these projects. And typically what we do is we just go right over the curb with an overlay, which you see here. And I've seen both these methods used successfully. One method here is you actually knock the curb head off, and the contractor used a jackhammer to do that, to knock that curb head off. And so you're left with just basically a pan, as you can see here. There was an old curb head here, and then they come in and just overlay the existing curb and gutter. Or you can just overlay the whole curb and gutter as it sets, and that's probably the more common practice that I see around the country, is this type of overlay. It's very easy to do. Of course, you have to have the grade behind the curb so you can afford this 4 or 5 inches here behind that curb. You have to make sure that you can afford that. There's no tripping hazards, but in most cases that's not a problem. So you can see that's 2 different ways to overlay the curb. So this project, this picture was taken in '97, and this is Parker Road, and it runs between Aurora, Colorado, which is where I live, and the town of Parker. It's a very, very busy road, as you can see here. And here we just overlaid the curb using a shoe on this paving machine. This was a Gomeco paving machine, and we just overlaid that old curb, as you can see here. And it was interesting. I was working on this particular project, and as an industry, we did not in '97 think this would work. And there was an engineer with the Colorado Department of Transportation that said this will work, and he put it into plans. And here's a shot in 2013. I drive this road all the time, and this curb has held up with no cracking whatsoever. So he was right back in '97, and we were kind of cautious as an industry, but that engineer, his name's Al Eastwood, he was correct. Here you can see overlay of a existing curb, and they're just doing it by hand, and these guys do a wonderful job. This is on that Thorncreek project where I showed you the night shot earlier. And the first step of the project was to overlay that existing curb, and that's what it looked like after they stripped the form there. And you can see here's basically an island within the middle of that parking lot. You can see other islands there. So the first step on this project is the contractor goes out and overlays all of these curbs. Now the other way to do it, if you have to transition into a curb for whatever reason, you can't overlay it because of constraints, then what you do is you actually remove a section of asphalt, and that might be one that looks like they're going one joint. You want to go 4 foot minimum. So you might go 1 or 2 panels depending on what drainage requirements you have. That really drives that decision a lot of times. So you'll pull out the asphalt in a section here and transition up to your overlay section. And that's one method of doing it, matching the existing curb, or you might match a point below a existing sidewalk and basically creating a gutter more or less here. So that's another way to do the transitions. This is another method I wanted to show you of construction. So this is a laser guided screed, and this is really a slick way to build a project if you've got a bigger project, and probably by a medium-sized project, I'm thinking about 100,000 square feet or so of parking lot, and typically you might see these laser guided screeds, and that's a really quick way to build these parking lots. This particular one was 3.5 to 4.5 inches of concrete on 2.5 to 4 inches of asphalt. We had a lot of variation on this one of asphalt thicknesses and the condition of the asphalt. And I'll show you, this is an aerial shot that I took of this project. This area here was an unbonded overlay. This was all bonded. This was remove and replace. We had to take this section completely out. It was in really, really poor shape. They had stored snow over here, so this section of asphalt was almost gone. And then this was a, let's say 4 or 5 inch concrete, 4.5 inch, I think it was, overlay for the roadway coming into the golf course. This is Meadows Golf Course out near the foothills. Thorncreek Golf Course, I just wanted to show you the condition of this particular project before we overlaid it. This was a 3 and 4 inch concrete overlay over 2 inches of asphalt. We went with 5-foot joint spacing on this one. And this is what that looked like once we finished this project. Interesting thing about this project is the city of Thornton, which is north of Denver, I want to say they did a $7 million upgrade to this golf course. They changed the layout. They remodeled that clubhouse. And this parking lot was the last part of that $7 million upgrade. And they really wanted a parking lot that matched the quality of the golf course that they had built, which was really nice. That was a lot of money put into a golf course. And so you can see their shop was down here. So this was all 4-inch overlay in these drives here, all the way back to this dumpster, because you can see the circulation pattern to get to that dumpster back through here. And this was all 3-inch overlay. A final project that I wanted to show you is this is a Pikes Peak shuttle overlay, and this was done in 2018 and 2019. I'm sorry, get my years mixed up. So this is a very large project. This is 4.5-inch concrete overlay. The asphalt's 5 to 7 inches. And the joint spacing on this is 6 foot by 6 foot. And here you can see that they're building this project using strip paving because it's very large. They're using a Gomeco paver. This is a 30-foot section, but they dropped back down to 24 for most of the project. So they built it in 24-foot strips. We started the project, as you can see here, with tie bars, but after we did a couple test strips, we had such a difficult time putting tie bars in that 4.5-inch section that the engineers at DIA agreed to remove those altogether, and we only put tie bars around a couple panels around the perimeter of this project to hold everything together. So this is the Pikes Peak shuttle lot, and here you can see a picture of the finished project. This is a finished project phase 1, and as we understand it, it's the largest concrete overlay for a parking lot in the country. It's about 26,000 cubic yards, 34.5 acres. And last year, just about, actually a little bit before this time, I think it was the beginning of April, the contractor, so he finished this in 2019, and last year in April, he had just brought all the materials out to the plant, and he was ready to jump into phase 2, which would have created a 62-acre project. It was basically the other half. Total concrete would have been 50,000. And within 3 or 4 days of him starting the operation, DIA called and actually canceled the project. So we were kind of heartbroken. But and they didn't postpone it; they canceled the project. So we don't know if it's ever gonna the second phase is ever gonna get built or not. Hopefully it will once the air industry recovers. So that's our hope anyway. So I just want to, we got a little bit of time. I just want to recap some of the things that that are important that we've covered. Number one is, I can't overemphasize, you have to determine the minimum thickness of the asphalt. If you find paving fabric, if you don't have enough pavement on top of the paving fabric, go to an unbonded concrete overlay. Consider those thickness charts as minimums. If in your area the contractor can't build those, you may want to add 1/2 inch of thickness to make sure that the contractor will at least build that minimum thickness. So they must be able to avoid thin sections. There's just no forgiveness in such a thin section of concrete. It's not like you're building 12-inch pavement. Make sure that existing asphalt is clean and not too hot. If it's over 120 degrees, put some water on it and allow that to evaporate. That will cool it down. Heavy coat or curing compounds critical. And then finally, ensure that that pavement is not prematurely loaded. Remember, we're dealing with a very thin section. You want to make sure you get 2,500 PSI before you allow any kind of loading on that, that pavement. I'll conclude with just a couple resources that are out there. Our Pave Ahead website, you can find case studies. Contact Theron. He can help you put together some design assistance plans or joint plans also. And we have a design program, pavementdesigner.org, which is free to use for parking lots or streets, roller compacted concrete. And with that, I will turn control back over to Theron. Here's some resources that are available, and we will, I think we have a few minutes we can address questions. I won't promise to have the answers, but I promise that we'll get the answers to you.
Thanks, Don. Great job with the presentation. We did get a question, and one question was, they asked if you could explain the difference between a bonded and an unbonded overlay. What does it mean, and what's the difference between the two?
Sure. So with a bonded overlay, we're putting concrete on top of the asphalt, and we are attempting to create a bond between those two pavements so that we have a composite pavement. So the asphalt and the concrete on top and the asphalt act as one pavement because that bond is very, very strong. Because of that bond, we can design those pavements a little bit thinner than an unbonded situation. Now, in an unbonded situation, we put concrete on top of asphalt. We don't count on any bond. So the asphalt is no more than a very, very good subgrade. And we'll design it based on a, let's say, a K value of maybe 200 or 250. So it's designing a concrete pavement on a very good subgrade, but there's no composite pavement. So that's the primary difference between the two. Unbonded will always be inch and a half thicker than a bonded concrete overlay.
Thanks, Don. Appreciate it.
You bet.
With that was all the questions. One thing I'd like to let everybody know, Illinois is a very pro concrete overlay state. We've had over 100 concrete overlays in Illinois. We do have a couple of IDOT projects that are concrete overlays. We have a lot of schools, a lot of car dealerships. We do have some nice industrial projects. We do have a whole subdivision in Lombard. We have several streets in Lombard. We have some in, I believe, Oak Park. So yeah, if this is something you're a little nervous about, there's no reason to be nervous. There are a lot of successful projects that are over, I think some of them are over 30 or 40 years old in Illinois. So if you have any projects that you want to look at to determine if they are good applications for concrete overlays, you can always start with a phone call with me. We work with Don and Luke McHugh at NRMCA, and we can help you with the design of that pavement, the construction of it, contractors who can do it in the area. And it's really much simpler than Don explained, right? These contractors place concrete all the time, and that's all they're doing. It's an extremely simple process. That's why we really don't have any problems or issues with it. So with that, we'd like to thank everyone for attending today. Our next webinar is on May 19th. It's called What's in Your Concrete Specification and What Does It Mean? This is going to be a fun webinar. We kind of talk about some of the things that are listed in specifications and kind of explain what they are, what they mean, how they apply to a project. We have found some concrete specs that contradict itself or maybe aren't written properly. So we kind of highlighted some of those to show people, hey, here's what was in a spec, here's why it wouldn't work, and here's what it should say. So I think this is just a great webinar to kind of make sure your concrete specifications are up to date, up to par, and we can help clarify some things. We have Scott Kelly from Ozinga and Nick Meristain with Prairie giving that presentation. Registration will open up on May 10th. I'll be getting an email out to everyone on that. And again, we do offer free engineering assistance. We work with all the engineers at NRMCA, especially our guy Luke. And again, it's free, and we just want to help you design concrete. Hold on 1 second here. We do have another question. So if you want to stay on, we do have another question. How is the bonding achieved, Don?
Yeah, and I actually I just posted the answer. So
Oh,
basically, for a parking lot, you just want a good clean surface. That's how it's achieved. And for roadways, typically milling is required, and the milling gives you a little more of a mechanical bond, if you will, because generally you have more traffic in roadways. But think about the bonding of concrete to asphalt is somewhat natural. I mean, you can see concrete spilled in a cul-de-sac when a development was built. It's still there like 20 years later, stuck on that asphalt. So there's an affinity for that bond to take place.
thanks, Don.
You bet.
With that, that's all the questions we have. So again, thank you everybody for coming. Don, thank you for the webinar presentation, and hope to
You bet.
see everyone again on the 19th.
Yep. Happy Cinco de Mayo to everybody.
Yes, thanks.